Good morning, students. In the previous video session, we have learned how to find the larger distance by using parallax method and radar method. And today we are going to discuss about theory of arrays in data, the important two terms accuracy and precision. You know that in science and technology, we are using experiments. So all these result from the experiment having some arrays. We cannot say that our experiment gives all our experiment gives correct answer. So there are some uncertainty in our measurement while doing the experiment. So this uncertainty, the term uncertainty, we can tell that it is error. You know that while doing the experiment, all the time we will not get the same value. That's what we are doing the experiment for several times to get the correct answer. Finally, we will take the average also. So this uncertainty only we are saying error, and this we have to know two terms about accuracy and precision. So what is this accuracy and precision? You can see the definition here. Accuracy refers what are how far we are from the true value, and precision refers to how well we measure. So this is a difference between accuracy and precision. Accuracy refers how far we are from the true value, and precision refers how well we measure. So this is what about accuracy and precision definition. Now I will tell you about what is this accuracy and what it means. Okay. So you know that assume that here you can see, you can go through this textbook example. I will explain you what is this given. Assume that your height, okay, your height is 5.9, okay, 5 feet 9 inches. So 5.9 is your height. So when you are measuring the first time by using a yardstick, so that is a stick we are using to measure our height. Assume that our original height is 5.9, but by using the yardstick we measured, we got first time 5.0. So that we can say our reading is not accurate. We measured by using the yardstick, the reading got is 5.0, but the original height of you is 5.9. But while measuring by using the yardstick, it is given that what 5.0, so that we can say that that reading is not accurate. I believe that you understand. Now assume that again you are measuring your height by using laser yardstick, advanced of this yardstick. So that what happened means, now the laser yardstick measured 5.9. Now we can say that your measurement is accurate. So this true value is also, we can tell that it is a theoretical value. So this is what about accuracy. So again, keep this example on your mind. Your height is 5.9. Your original height is 5.9, but by using the yardstick measured, the measured value first time you got it is 5.0. So we can say it is not accurate. So again what again your height is measured by using a laser yardstick. That time it is The value got is 5.9. Now we can say that this measurement is accurate. So this is one example for this accuracy. And you can tell that the same example for precision. How you can tell means you are measuring your height by using yardstick. You have noted that first time 5.0, second time 5.0, third time 5.0. So several time you measured, many times you measured, every time you have noted that 5.0, 5.0, 5.0. Now we can tell that consistently you are measuring your height is 5.0. So now you can tell that it is not accurate because your original height is 5.9, but consistently continuously I am getting what 5.0 by using the yardstick, so that I can tell that it is precise. So that is what our definition. Precision means what? How well we measure. How well we measure. That's what definition. You see, 5 times you are measuring by using the yardstick. The 5 times you got 5.0. Accuracy, you see how far we are. Okay, so that is a difference. And here I told about the example. And you know that sometimes engineering field, construction field and all, engineers giving the project based on what while they constructing the road, bridges, house or anything, while they construct these thing and all, when they are giving the quotation for this construction work or any engineering work, they are giving what some precise value. Not that value is maybe not accurate. Maybe suppose we are going to build a house, we are calling on engineer and asking how much will come, so that he will tell that maybe 18 lakh. He will tell our plan, so he will tell that 18 lakh total money you have to use is 18 lakh. So that time he is just saying what a precision, a precise value. Maybe it won't be accurate. Maybe below 18 lakh will come, maybe above 18 lakh will come. So that we can tell that it is precise. So next example, many examples given here. Next example you can see, assume that the temperature, whether you are sitting inside the house, outside your house temperature is 40 degrees Celsius. So 40 degrees Celsius is outside temperature. So you are sitting inside the home, outside temperature, original temperature is 40 degrees Celsius. Now really you are checking by using a thermometer. We can see what will happen. You see, while measuring this temperature by using thermometer, you got correct, so that we can tell it is accurate. You see, because the original temperature outside the room is 20 degrees Celsius, 40 degrees Celsius. Now, by using the thermometer, they measured, they got sharp 40 degrees Celsius, so that we can tell it is accurate. Suppose you are writing this measurement in a paper, continuously you are writing, 5 times you are measuring and 5 times you are writing, so that every time you got the same value, you can tell that it is precise. Now one more example is given, same example only. So refrigerator temperature you are measuring by using a thermometer. Assume that you are measuring the temperature of inside a refrigerator, you are measuring. So that you are writing 10.4, 10.2 degrees Celsius, 10.3 degrees Celsius, 10.1 degrees Celsius, 10.2, 10.1, 10.1, 10.1. So you are writing all these reading, but assume that the inside refrigerator original temperature is only 9 degrees Celsius. So whether this reading is accurate or precision, we can tell that what you wrote, these all readings 10.2, 10.1, 10.4, all readings are, we can tell that it is precise, because all the value you have wrote is very close to 10 degree. Very close to what? 9 degree, that is what everything, all the reading is 10, 10, 10, 10, 10 you wrote. So that we can tell that it is precise. Now on the practical example, you can see here diagram. Here 3 diagram you can see. This is what we are saying, target shooting. And here you can see 3 diagram. So in the first diagram you can see, this is a midpoint. So while they throw the shots, this arrowhead has to point on this midpoint. Okay, but you can see this diagram. You see all the arrowheads, all the shots. What happened? All the arrows have only reached around this midpoint, or you can tell bullseye, midpoint. So you see here many arrows, many shots are done, but all these shots are around this thing only. It didn't reach nearby. So that we can tell that it is not accurate, not precise. The second diagram you see, it is far from the midpoint, but all are nearby. So that we can tell that it is not accurate. Is it accurate? It is not accurate, but it is precise. You see, all the shots are in one place. Now last one you see, all the shots are on target point. So that we can tell this diagram is accurate and precise. So you can just go through this accuracy and precisions example. Just to take a screenshot of this and go through. Next very important 5-mark question is error in measurement. Here you can see some of the types of the errors. It is one of the very important 5-mark question in this unit. So error in measurement. So first thing, what is meant by error? You know that before I told the uncertainty in the measurement is called an error. And here you can see the types of error: random error, systematic error and gross error. These are the 3 possible errors. So let us discuss what is these types of error. First one is systematic error. So it is reproducible inaccuracies that are consistently in the same direction. These occur often due to a problem that persists throughout the experiment. Systematic errors can be classified as follows. So you see, when we are doing the experiment, some errors are occurring due to the instruments. When we are doing the experiment, we know that we use many instruments, ammeter, voltmeter, rheostat, so like that, many devices, many instruments we are using. So whenever you are using a wrong instrument, what we can see is always in our reading that error will come. Not only that, the another thing is, suppose you are doing a heat experiment, so that time and all, if there is a change in the outside pressure or outside temperature, then carelessness of the person while doing the experiment, then least count error. So these are the problems occurring due to, these are the problems why there is a systematic error occurs. So let us discuss what are the types of systematic errors. In that, first one is instrumental error. When an instrument is not calibrated properly at the time of manufacture, instrumental error may arise. If a measurement is made with a meter scale whose end is worn out, the result obtained will have errors. These errors can be corrected by choosing instrument carefully. Let us see what is this instrumental error. You see, while doing the experiment, we are using the instrument. Sometimes the instrument is not scaled properly. That is what calibrated properly. We can see that some instrument, the readings writing 1 to 10, maybe 0.1, 0.2, 0.3. While they are writing, while they are dividing this, maybe in between 1 or 2 line missing means that is what instrumental error only. That is while manufacturing, they are making that errors. Also, we are using a ruler. Sometimes you know that your ruler end is broken. Your ruler end part is broken. That is what worn out or broken, or you can tell that worn out. So at the end part, readings are not seen clearly. So that you are doing the experiment with that ruler means that time also this instrumental error can occur. Then the second one is imperfection in experimental technique or procedure. These arise due to what limitations in the experimental arrangement. This is what I told. When you are doing the experiment, maybe you are doing experiment with heat. Heat means what? One experiment is there in a calorimeter. In a calorimeter, we are putting the hot water. Then we are taking the temperature by using thermometer. Like that one experiment is there. So if the calorimeter is not insulated properly, then what heat loss will be more, or heat loss value, heat reducing value will be changing. So that in that experiment we will not get a accurate value. Another error, the third type of error is in systematic error. The third one is personal error. Personal error, you see some of the, assume that you are doing the experiment. So while doing the experiment, there are some initial setup. If you are not doing that initial setup properly, that is what that make error in that experiment. So, or if you are doing any carelessness while doing the experiment also, this personal error can be occurred. So that is what these errors are due to individual performing the experiment, maybe due to incorrect initial setting up of the experiment or carelessness of the individual making the observation due to improper precautions. That is what I said. We know that maybe 11th grade students, you all did the last year Ohm's law experiment. While doing that Ohm's law experiment, you have to give the connections properly. That is what initial setup. So that initial setup you are not doing properly. So there must be some error which will occur in that experiment. That is what personal error we are seeing. Next one is error due to external causes. In these errors due to external causes, what we can say is some types of experiment. So this heat experiment and telescope and micro. So while doing some type of experiment, one example I told already, heat experiment. We are measuring the temperature. So you are putting the water in a calorimeter. Maybe you are measuring the temperature by using thermometer. The outside temperature is very cold, means what will happen? This hot water fast it will get to cool down. So when it get to fast to cool down, our readings won't be accurate. That is what external conditions, error due to external conditions. So what I told is telescope is sometimes rainy season and all, if you are focusing some leaf or something, maybe that visuals won't be clear because of this cold climate or watery conditions on the leaf and all. So like that errors will occur due to the external causes. So the change in the external condition during an experiment can cause error in measurement. So this is what the fourth one, and the last one is least count error. Least count means we know that the smallest measurement, no? Smallest value that can be measured by using measuring instrument. Suppose we are taking a ruler, we know that like these divisions are marked, no? 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. So here you can see 0, 1. This is what a ruler. So how many divisions are there? 10 divisions. So 1 divided by 10. This is what a least count error. So suppose we are taking a protractor. When we are taking a protractor also, we know that in that protractor also there will be divisions like this. So for all the instrument, not only the protractor and the ruler, in that ammeter, voltmeter, everywhere what like this smallest value we can measure. That is what a least count error we are saying. So least count error means what? It is the smallest value that can be measured by the measuring instrument, and the error due to this measurement is called a least count error. So all the instrument have some value, smallest value we can measure. I told ruler means you can divide that by its division. Ammeter also, voltmeter also, all these instrument we can find out the least count, that least count value. So we will get one small value. That value is what? The reason why there is a least count error occur during the experiment. And the next one is random error. Random error means what? This is what we can tell that unpredictable variations in the experiment. So it is what not predicted. Maybe some changes in the temperature, some changes in the voltage. If you are doing a current experiment, maybe some voltage variation will occur. So this, because of this and all, there are some error occurring randomly or unpredictably. So that is what a random error we are saying. And personal error. Sometimes while you are doing the experiment, some personal error occurring because of your carelessness and carelessness. So this time, this and all we have practiced. Sometimes we are doing the practical, we may occur some error. Maybe we will read in the experiment 10 centimeter or 10.5 centimeter. 10.5 centimeter you are reading while doing the experiment, but you are writing in the paper, you will write 10.4. So this is also, you can tell that personal error. So these all occurring randomly. So you can tell that random errors may arise due to random and unpredictable variation in experimental conditions, like pressure, voltage, and personal error also we can tell data, and these error we can tell data chance error. So we know that when you are doing the experiment and all, we used to we can avoid the personal error by repeating the experiment. You can repeat the experiment, you can do the experiment several times, take many readings, then you can do the calculation. So suppose first time A1, second time A2, third time A3. So n times you are doing the practical, so n times you did the practical, all the value you are adding, then what? Divided by that number, all these n times. So if you are finding the average by using this formula, you will get what? You will get the correct reading. So you can write this formula AM. So is equal to this n, we can take it out 1 by n. I am taking out then sigma summation AI. Instead of this I am giving here I is equal to 1 to n. So AI means, suppose I is equal to 1 means here A1, I is equal to 2 means A2, I is equal to 3 means A3, I is equal to n means AN. So I is equal to this, how you can read means AM is equal to 1 divided by n summation of I is equal to 1 to n AI. So this is what the formula you can use. And the last one is gross error. These are occurring due to the sheer carelessness. Sometimes while doing the practical exam and all, we know that some fear occurring. We also have that exam fear and all. So due to this fear, while taking the reading, we are doing some error in the experiment. That is what the gross error. So you can see some of the example: reading an instrument without setting it properly, taking observation in wrong manner, without bothering about the source of error and precautions, recording wrong observation, using wrong values of the observation in calculation. That is what a gross error we are saying. Okay, without setting the experimental setup, we are taking the reading. Then what are taking the readings in wrong manner. Then what are you are checking the reading 10.5 and you are writing the reading 10.1 or something. So wrong observation and using wrong values. That wrong value you are using for calculation. These are the reason why gross error occurring. And my dear students, this is one of the important, very important 5-mark question. You can take a screenshot and study. Types of error: systematic error, in that instrumental error, imperfection in experimental technique, personal error, error is due to external cause, least count error, random error. Then what error? Gross error. Okay, you can take a screenshot and study this. It is very important question in this unit. Thank you all. See you. Bye bye.